All right. Some of you are asking for some video help for question number two. All right. So let me produce a video and let's see whether this could be useful. All right. So you are considering purchasing a machine to produce golf balls. All right. The cost of the machine is $100,000 and lifespan is about 8 years. The machine will have annual production of 550,000 balls. The price of each golf ball is 20 cents and it's going to go up by 10% every year. And the material used to produce a golf ball cost 8 pennies and it's going to go up by 2% per year. To operate the machine, you will need two workers. Each actually earns an annual salary of 30,000. According to the contracts, their salary will rise by 7% a year starting in the third year. The real discount rate is 4%, expected inflation is 5%, corporate tax rate is 40%. Okay? So what is the NPV using nominal cash flows or nominal values? And repeat the calculation using real values. All right, so there's a lot of information here, and I like to actually, build a timeline and start analyzing. All right, so we just need to calculate the MPV by considering all the information provided in the question. All right, and this is actually for 8 year lifespan. Okay, so I'm going to actually do 8 years here. All right, so I have 8 periods. And let's look at the machine cost. Okay, the machine cost right now is actually negative 100,000. Okay, and annual production. All right, so annual production that is going to be 550,000. Okay, and this is actually for every year. Okay, the production does not increase. All right, it's from the same machine. And let's look at the golf price, golf ball price. Today is actually 20 cents. And golf ball price increase. And it's going to go up by 10% every year. Okay, so it's 10% across the board. All right, so immediately I can calculate the golf ball price for the following years. Right, so this would be the price for first year, and I can copy this across. Okay, so by year 8, the price is going to go up to 43 cents. All right, and you have the material cost. Material cost is actually per ball. Okay, so the material is actually costing uh, 8 cents. Okay, and it's going to go up by 2% each year. So material cost is, let's look at material cost, that's 8 cents now, and it's going to go up by 2% every year. So let me just put down um, 8 cents, and the cost increase, material cost increase, and that's going to be 2% per year. Okay, so it's 2% per year, and so I can look at the material cost per ball. So this is the material cost per ball for the first year. All right, and I can copy this across. Okay, and let's look at the salaries. Two salaries, two worker salaries. All right, so right now they're making 30,000 each, so that means total of 60,000, and salary increase is 7%. So salary increase is 7%, but this is actually starting in the third year. Okay, 7% increase, right, for each of the following years. So a salary for years 1, 2, 3 would be 60,000. Oops. All right. So for years 1, 2 would be 60,000, and then for year 3 is going to increase by 7%. Okay. So that is 64,200. All right. So you have the salaries, and the last in year 8, the salary together would be $90,044. All right. So now let's look at the real discount rate. So the real discount rate, that's 4%. Okay, and we also have inflation rate. Inflation rate, this is actually 5%, right? And you also have the tax rate, which we'll use. Based on the real discount rate and inflation rate, you can actually calculate the nominal discount rate. So I'm just going to do the nominal discount rate here. All right, I know there's a Fisher equation, so I would have to do the Fisher equation here. 1 plus the real discount rate multiplied by 1 plus the nominal discount, 1 plus the inflation rate minus 1. So that's 9.2%, right? So I don't know why so it's giving me so many zeros, right? So 9.2%, right? And let's look at after tax cash flow. Well, before I do that, I need to consider the depreciation. So let me just do annual depreciation. Annual depreciation is going to be $100,000. That's the machine cost over 8 years. Okay, it's a straight line depreciation. All right, it's not clearly stated, so let's just make it simple. $12,500 per year. All right, and let's look at the after tax cash flow. Okay, so let's look at the first year. So you're going to produce this amount, and you're going to sell this amount for this price per ball. Okay, and you're going to actually subtract the cost of the materials used to produce this amount. So this is the amount you're actually producing, and you're actually paying this price for each ball. Okay, so and then you're also taking out the worker's salary. So this is your earnings, all right? And then let's take out depreciation, okay? And let me close this, all right? So now let's actually pay tax. So 1 minus the tax rate, which is going to be 40%, all right? And the way I do this, I knock off depreciation and I pay tax, and now I need to put back depreciation. Okay, so this is the after-tax cash flow. It's 14,672, and I can copy this across. I have 61,519. All right, so we have the after-tax cash flow, and now let's look at the MPV using nominal, nominal discount rate. All right, so I'm just going to do the MPV here. Nominal discount rate is this number, and I'm taking all these cash flows. All right, and I'm going to put back the initial investment. All right, so this again is a big percentage. So let me just format this as a dollar. Oops, this is a dollar. I want to format. Okay, so it's going to be $83,951.47. All right, so this answers the first part. Now the second part, this is asking the calculation using the real values. So the real values, we need to look at the real cash flows. All right, so I'm just going to look at the after-tax nominal cash flow, and I'm going to deflate this at the inflation rate, which is actually 5%, and I want to actually do all the deflation for the after-tax nominal cash flow in the other years. So I'm going to actually lock down this cell reference and raise to the power of 1, because the 14,672, that is the price with the effect of inflation. So I need to actually deflate everything. So this is how you do it. All right. So it's going to be 13,973, and I can copy this across. All right. So you have 19,404, and so on and so forth. Okay. So now I can actually look at NPV using real discount rates, and hopefully I can produce the same answer. So this is equal to NPV. The discount rate is the real rate now. I'm taking all these real cash flow present values. Okay, I'm taking all these real cash flows, and Excel is doing the discounting for me. All right, and I'm putting back the initial investment. So this way, yes, I'm able to replicate the same 83,951. All right, so this is question number 2. I hope this is useful.